Well, hello again, everybody. I am Dave Lee. You heard me earlier, VP of Sales, Global Workboat Responsible. But I get the question a lot, what the hell do I actually do? And the easiest way for me to tell people what I do is, I had the same question. You heard me talking about my son already, but my 11-year-old daughter, they're both in the room, and I've worked for ABB for 4 years, and they both looked at me and said, Daddy, I don't know what you do. Can you tell me? So I decided to be a little bit of a smart ass, and I said, so I sell electric and hybrid propulsion systems that may or may not have azipod propulsion into the workboat industry that I cover, which is dredge, workboats, offshore wind, and marine construction. They both looked at me like my wife normally does, that I'm absolutely crazy. And so I simplified it for them. I said, well, I do Teslas on the water. And my 8-year-old, as you've heard many stories already, looked at me and said, wow, you sell Teslas? I was like, no, buddy, I don't sell Teslas. And immediately he picked up his phone, went back to YouTube, and walked out of the room. So to simplify it, I sell Teslas on the water. I sell electric propulsion systems for the workboat industry. I absolutely love what I do. But why am I here today? 2 reasons. Number one, Austin asked me to come here today. That we're going to turn my buddy Austin down. But number 2 gets into this. Why do we need new technologies? And several things. Number one, everybody knows this. We've talked about it already and what the IMO goals are. Number 2, we talked partly about this already as well. Zero emission ports. 2035 Long Beach, Port of LA, Port of Vancouver. As you can see, it's very West Coast swung, right, as we've talked about already. But as you see, it's starting to move its way across the U.S. Even the one for me it's kind of crazy, the petrochemical heart of the U.S. and Houston saying 70% carbon reduction by 2040. So that's huge. The areas that we're operating in is really putting those pressures on us. And that applies to cold ironing, idling in the fleet, standby at the dock. The new carb rule, if I heard it correctly yesterday, for a tug operator, if you're going to sit more than 15 minutes operating on a generator, you have to plug into shore power now, where normally they just hang out at the dock running a genset. So pretty big implications just from the port side. Feel great that I actually did put BP up here since I was on the panel with BP. But this one, I don't even have to put names to. Everybody knows the goals of the oil majors, their net zero carbon goals. And a lot of it comes down to also their supply chain and who they're using for horsepower. So for instance, a lot of Austin's customers are being pushed for this because they operate for these companies. And then the next one, this one's really hard to see, but if you just Google carbon tax map, and this is the World Bank from 2021, this shows you where there's currently either already carbon tax or it's in legislature somewhere, some way, somehow. Again, it's no surprise you see the West Coast of the United States and how it's starting to be adopted here. So like I said earlier, with the scrubber barges, you could do an internal combustion engine that has emissions from it. However, if you emit carbon, eventually, if you're in one of these areas, and it's going to just get larger, this is 2021, you'll have to pay a tax on that. Okay, so that's really why I'm here, because people are looking at what technologies, how can I get through all these pressures that we have in front of us? So when we look at it from ABB, what we are is we are an electrical company. We, my boss is saying on LinkedIn and elsewhere, and people may have seen it, electrify everything. We're also a major controls company, so automation and controls, which fits perfectly into the way that the industry is going. Fortunately, I have workboats up here because I'm in the workboat guy. I did slide a ferry into the bottom left, especially since we're here in Seattle. But these are all projects that we have at ABB. So what the real thing I want to point out here is either you're making the diesel more efficient or you're trying to replace some or all the diesel with an alternative fuel or electrons, right? So top left, PTO, PTI, battery system. This is a LNG tug that we have in Singapore. In the middle, diesel electric. These are push boats that operate on the Amazon River system in Paraguay, Paraná River system in South America. Top right, that's a diesel electric with battery tug for Japan. Bottom left, I think everybody in the room probably knows exactly what project that is. It's kind of a dual project as well, not just short diesel electric shore power, but the full intentions of full electric. Crowley's full electric tug for Port of San Diego. Bottom right is a hydrogen fuel cell boat in Lyon, France. And then we have other ones. This is the Yamal tug for the LNG terminal in Russia, and Hydrogen One. And really what it comes down to, as we go through this chart, our involvement becomes more and more and more on the ABB side of things. I like the picture that Mike and the team came up with all the boxes and the arrows showing all the different components. There's a lot more interaction in those components than what's really on that picture. And so we're not only supplying the switchboards, the motors, the batteries, but we're also doing all the automation to make this thing work. And I'm an old mechanical engineer. One of the things I like is those really cool, sexy gearboxes and engines and those types of things. But when it comes to electrical equipment, it's a bunch of lights on the front. Cool looking, but what really makes them work is all the automation stuff behind it, which is much more difficult than actually doing what's inside that box itself. So with that, one of the things that I always like to point out, especially in the workboat world, Lydia put up the ferry profile. I'm in a different world. I really am when we look at workboats, and especially Hydrogen One. 85% of operational time is less than 50% engine load. And this is fairly standard on any of these boats. It's absolutely ridiculous. And what makes it even more ridiculous is, like I put in the stars section here, diesel engine most efficient above 50% load. We're hardly ever there. So you're so inefficient in what you're doing. And oh, by the way, in a standard inland boat or a tug, you have both main engines and a genset running this entire time to cover this. For Hydrogen One, what we're looking at is a lot of the times we may be just running 2 reformers and 2 fuel cells, and the other ones are just sitting idle. We're going to use the power that we need versus having everything online running very inefficiently. So let's go forward and look at how ABB looks at the pathway to carbon-free shipping. There's a lot of things on the screen here. I'm not going to walk through every one of them, but it really kind of shows the energy carriers at the top, the technology at the bottom, and kind of where we're at today is here in the green. We're trying to get to things like carbon-free hydrogen. We spoke of it earlier, whether that's through solar or wind. But the most important thing that here is carbon-free hydrogen PEM fuel cells are really kind of leading that right now in a lot of the segments that I look at. Fuel cells have been around forever. I will still reiterate this. As we look at the bottom side here, we're still looking at getting from the kilowatt scale to the megawatt scale in a single reformer, a single fuel cell, those types of things. But again, that's rapidly developing. So, and then I always like to show kind of where each one of the industries are. What's really interesting, I'm an old brown water guy, old towboat guy. I thought already in my 4 years at ABB, I probably would have just sold diesel electric or PTO, PTI towboat. This map, because of Hydrogen One, kind of needs to be leaped. We're already to a reformer boat compared to a diesel electric or PTO, PTI. So probably need to change that for next time, but that's currently where we stand. Now, hydrogen as fuel, and as the way that we look at it, what's limited to the adoption, volume compared to diesel, right? Dave talked about that a minute ago. Bunkering requirements, we've looked at several projects on bunkering hydrogen. It's not the easiest thing in the world to do. Availability, what makes it attractive? All these things. A fuel cell powertrain enables increased operational efficiency compared to diesel. Scalable, kilowatt to megawatt, right now we just stack them up, essentially, and decrease maintenance cost. I think we talked about on the panel earlier. Hydrogen One, I don't know of really any moving parts you're going to see. If you go back to the thrusters, because they are L-drive thrusters, there's no shaft lines, any of those types of things. You probably look in between where the adapter is, and you'll see a shaft rotating. A couple of the pumps, you may be able to see the shaft rotating on those. Other than that, there are no real moving mechanical parts in this system. So really what we look at, again, as hydrogen has all these benefits, but they have all these roadblocks as well. That's why we looked at methanol and it's ready today. You can really convert that methanol hydrogen at the point of use versus having a big hydrogen tank either on the vessel or on the shore. And what I like to show on the bottom here is just the chart. Everybody knows that methanol content is not, or energy content is not as great as gasoline, but you can see where it's on the chart compared to a lot of the other ones that are out there. And then again, the green methanol has potential for enhanced emission savings. We're not that far off. And the other thing that we look at when we look at this system, you will get some increased efficiency because, again, like I said a minute ago, you're only going to run the reformers and the fuel cells that you need in their optimal range. So when you compare that to the traditional diesel system, the efficiency of the system, overall system is increased. So in closing, and I'm going to get out of here right after this, I promise. But one of the things that I really like in the way that ABB looks at future-proofing the marine fleet is really the first one. We are here to enable technologies that power the world without consuming the earth. We've consumed the earth for way too long. We've been doing the wrong things for way too long, and we need to change the way of thinking, and that's what we're here for.